Well, apparently we decided to do another question, so here's a third video to go along with this review. So just another short one, just one last question. So it says this: on the day you were born, your grandparents gave you $1,000. Unfortunately, you were too young to make a decision about what to do with the money, so your parents had to make a choice. Your mom's idea was to put the money in a cute little piggy bank. Each year they would add $50 to the bank and then give it to you as an 18th birthday present. Not too bad, right? Your dad works at a bank, and he thought it would be wise to put the $1,000 into a high-yield savings account that adds 4% of the balance every year. On your 18th birthday, he wanted to take you to the bank and withdraw all the money. Which plan will have the most money on your 18th birthday? So, the question here is asking us to compare, right? So, we can start off with some models. The first, let's do your mom's idea. So we've got the $1,000, right? So for making a table, good model to start. We've got years, right? Because it's every year, and money. So when you were born, you had $1,000. Okay. Then every year they're adding 50. So we should be able to see that. Okay, we're adding 50 here. This is going to be linear. So 1,050, 1,100, 1,150, you can kind of see the pattern. 1,200, 1,250, 1,300. Okay, now we probably don't want to keep going that route, right? So let's make an equation. So y equals, we started at $1,000, we're adding 50 each time. Or you could write it with function notation and in slope-intercept form. Either way works. Okay? So we could see it that way. Now, could we graph it? Yeah, we could easily graph this as well. We'd have to start clear up at 1,000, and it would look like, well, now it'd be discrete, wouldn't it? Because you're not getting the money continuously. You're getting it every year. You're getting 50 more. Okay, so it looks something like that. Alright, so once we've got that equation, we need to figure it out for the 18th year, right? That's kind of what they wanted to see. So if I use that equation, we can take a quick shortcut to get that where we want it to be. So we put 18 in for x. So what happens when our input is 18? What do we get? Well, we'd go, let me get my calculator out, because I don't know 50 times 18 off the top of my head. That would be 900 plus 1,000, so 1,900. Not too bad, you almost doubled your money, right? Okay, so that is that way of doing it. Okay, now let's see about another. So now let's take a look at what your dad wanted to do. Okay, so that was what your mom. So he said we put it into a high yield savings account that adds 4% of the balance every year. So remember, we use that formula, the principal times 1 plus the rate to the t. Okay, so our principal was $1,000. Okay. Actually, there's two ways we could do this. The first way would be to just try it on your own, right? Would be to make that table and go same thing. Okay, 0, 1, 2, 3, 4, 5, 6, and then 18. Well, we start with 1,000, and every year we're timesing by 4%, right? But when we think about it, we're taking that $1,000, which is 100% of your money, and we're adding to it 4%, right? So really it's 104% that it's growing, so it'd be timesing by 1.04. That's really how we should think about it when we're talking about that part. Okay? So we'd multiply it by 1.04, so we would get, times that by 1,000, so we'd get 1,040. Okay, so it looks like the other way would be better at that first year, right? 1,081.6 D cents, then 1,124.86, then 1,169.86, 1,216.65, then 1,265.32. I'm rounding these decimals. 1,000, oh, not to 18, right? Okay, so far, looks like we're losing money to that, right? But let's come up with an equation, okay? So that equation, same idea, would be y equals our start number, 1,000, times 1.04 to the x, okay? Or doing it with the f of x, same thing. We don't really want to put it backwards. So if we did that with 18, get 1,000 times 1.04 to the 18th, okay? So we type that in our calculator, 1,000 times 1.04 to the 18th, and that would give us 2,025.82. Okay, so pretty obvious that which will get you the most money? Your dad's idea, right? Because you earned a little, you doubled your money at least, and some. So not too bad, a little bit better than the other one. Now if you keep it in there, it'll definitely jump up. Say we did it another 5 years. 1, 2, 3, 4. 1, 19, 20, 21, 22, 23, 24. You get about, 2,500. Whereas with the other, you're definitely losing it. So if we graph this one, it would look something like that, going up. So now, interestingly enough, we do have that formula, okay, that principal times 1 plus the rate to the t, okay, which is basically what we did. Watch, our principal was 1,000, right, times 1 plus our rate was 0.04, and our time was 18. So I could have put it in there and got that same answer for this. But notice, what if we simplified this? 1,000 times 1.04 to the 18th, what does that look like? Looks like our equation, doesn't it? So that's what it's based off of. Okay, it's based off that equation. Now, just to show you kind of a good graph to compare the two, here's a graph that I did on Desmos. So if you're looking at this, you can see we start with the same principle right here, right? They're intersected right there. So first, the red line, which represents our linear, your mom's choice, okay, it's growing quicker, right? Right until about here, okay, which is when they would equal. And if I look at my graph, that's about 11.9 years, so almost 12 years. Okay? But about 12 years, that's when you're getting the same amount. And then the blue one, which represents your dad's idea, that's our exponential, okay, it takes over. And notice here, these are the points when you're 18 years old, and obviously you're earning more money with the first one. So there we go. Different models, different ways to portray it, but they all help you understand the same idea, that the best one was your dad's idea. So that's the answer. That's what we're looking for, but we need the models, the ideas to show us that that's the reason behind it.